I'm João, hello, and I have been working here at NuNet for almost 1 year and a half as a software developer. And while the researching didn't exist before officially, since my first days here, I've been mainly researching on important features and frameworks and how they could be integrated here at the NuNet platform. So today we're going to talk about job orchestration, also called scheduling sometimes, and why we've been putting a lot of focus on it on the last few months. So before anything, what is a job? So a job is a software program that runs on a compute provider machine that is deployed by the service provider. The job orchestration happens within the NuNet core component, which is the DMS for device management service. It is the application used to participate on the NuNet network, and it is also responsible for the whole job orchestration and the job deployment workflow. The job orchestration refers to the management of the job deployment workflow. It is also responsible for the control of actions upon deployed jobs and also the history management of the finished jobs. With control of actions, I mean when a job is already deployed, you as the service provider, the user who deployed the job, has certain controls upon it. Like you can stop the job, you can retrieve logs from the job, put some sort of dynamic validation on it, and so on. So job orchestration is not only about deploying the job per se, but also a lot of actions and management related to it. Before continuing, let's clarify some more things. Service provider refers to an user running DMS who deploy jobs, and a compute provider refers to an user running DMS who lends their hardware resources so that service providers can deploy their jobs there. Job orchestration mostly refers to DMSs acting as a service provider. While that's true, it is important to note that local management of jobs is also necessary for compute providers, as they need to manage the jobs currently running and those that have already run on their machine. That's an important note because we decided to treat those different kinds of job management differently. One more clarification: machines running a DMS can act both as a service provider and as a compute provider at the same time. And what is the importance of working on the job orchestration design and implementation? So first, let's dive into the current job workflow. So the current GMS version was built with the ML GPU milestone in mind, where service providers would pay to deploy an ML job within a compute provider machine for a finite period of time. So while that's an important use case that we successfully made it is not the only one that we want to enable. Based on that, the current state is: so service providers can only deploy one job at a time. So while one job is running that they deploy it, they cannot deploy more jobs. And the same goes for compute providers. Compute providers can only run one job at a time. So while one job is running locally, they cannot receive more deployment requests to run more jobs. Right now, it is possible to deploy only batch jobs. For example, an ML job that will run for 3 hours in a single machine. So other kinds of jobs are not yet supported. Only Docker executions are supported because the job deployment workflow is coupled with the Docker execution. So compute providers should be able to run multiple jobs. Service providers will be able to deploy multiple jobs. NuNet will support different kinds of jobs, different types of jobs, like running longer running jobs, distributed jobs, pipeline workflows, cron jobs. Also, NuNet will allow jobs to run on different executors like WASM, Firecracker, and some others. NuNet must support optional and pluggable validation workflows for jobs. And a side note here, validation refers to the process of validating if the output of a job is correct or if the job was correctly executed. And also, GMS will be capable of monitoring all running and deployed jobs and their stats with the ability to terminate them or take or some other actions. And what is the current status right now? What we are doing, what is left to finish the job orchestration design and implementation. So we started by directly designing the orchestration workflow based on the requirements, but we decided to pause the design itself and see how other similar frameworks and platforms have built the same process we are trying to create, while also looking into some concepts of the actor model. So, looking for some sites, we spent some time looking for inspirations from platforms like Nomads and Kubernetes, actor models implementations such as Akka, and other computer models and frameworks like IPVM. And right now we are focused on finalizing the specifications of the orchestration workflow, which will be in turn followed by the design and the implementation. Alright, so that's it for today. Feel free to drop any thoughts and ideas on our Discord. We are very active there. Also, if you want to do a more hands-on contribution, just go to our GitLab issues and you can participate on the discussions there. So thank you. Bye bye.